how does the RSA key generation mechanism work? Well, first we choose two large prime numbers, p and q, and then the modulus. N is the product of those two prime numbers. Then we choose a public exponent that has to be smaller than n and co-prime to n. In most public keys you will find one of these numbers, 37, 127 or 65537. They have the advantage that they have a low Hamming weight, which speeds up certain kinds of algorithms, which is not important here, but most public keys have one of those values. But in principle, every value is possible as long as it's co-prime to n. The private exponent d now is the multiplicative inverse to the public exponent modulo phi of n. Here phi of n, since we use two prime numbers, is p minus 1 times q minus 1, right? Because n is a product of two large primes. So now, since we as the creator of the private key know these prime factors, we can calculate this phi of n. Since we can just calculate this equation, and therefore we can calculate the secret exponent d. Now, a person that only has our public key only knows the product of the two primes and our public exponent, and therefore can't just calculate phi of n, because to calculate phi of n, he would have to factor our modulus n. And factoring such a large number, especially if it only has two prime factors, it's a semi-prime, is a hard problem. That is currently computationally unfeasible, so you can't just calculate the private key from the public key, because to do so you would have to factorize n. Now, how this works and why this encryption method that we've seen a couple of slides ago, why this works, we're not going to go into that, but the proof is quite simple and quite nice. If you want, you can look it up in your favorite math textbook.